The next question I had was on problem 23 on section 4.2. In this problem, we're asked to find the intervals of increase and decrease. My suspicion is the difficulty with this problem is the same with the previous homework problem we discussed, which is finding the critical numbers of a trig function. So we start with f at x equaling 3 cosine of 3x. And of course we need to take the derivative to find my critical numbers. So the first derivative here would be negative 9 sine of 3x. And then at this point we had set this equal to 0. And of course we could divide both sides by negative 9 to get 0 is equal to the sine of 3x. Now, just like we did when we had the cosine function, we're going to write over here sine of theta equals 0 and determine when the sine of theta is equal to 0. Well, this is true for theta equals, well, dot dot dot, negative 2 pi, pi, 0, pi, oops, I managed to type something on my keyboard here, pi, 2 pi, dot dot dot. And if we want to write this in a shorthand notation, again, you can pick any value, so let's go ahead and pick 0, and then it'd be plus n times pi. So this would just be n times pi. So then what we'd get here is we'd get, going back to this problem, we'd have 3x is equal to n times pi. And so x is n times pi divided by 3. Now we have to figure out which one of these values are in the interval that we're given. So we have n and then x. Why is my x not writing here? There we go. X. And so again, just pick some values for n and see if we have enough values here to satisfy my interval. Well, clearly if n is 0, we get 0. And then if n is 1, we get pi over 3. If n is 2, you get 2 pi over 3. And so we might have to do another one. If n is 3, we get pi, which is the endpoint. So we don't have to go any further, because now I've reached the endpoint. And then if we do the same opposite, you get negative pi over 3, negative 2 pi over 3. Now it's just a matter of writing all my critical numbers down in my intervals. So I'm going to draw a fairly large number line here, because I have a fairly large number of critical points. I'm going to go ahead and put a square bracket here for negative pi, and a square bracket here for pi, because these are going to be my intervals. And then we have, what do we have here? 1, 2, 3, 4, 5 critical numbers. So negative 2 pi over 3, negative pi over 3, 0, pi over 3, 2 pi over 3. Now we need to test something in all of these intervals in order to determine whether or not we're increasing or decreasing. I'm not going to test all the intervals. I'm going to test just a couple here to illustrate it. So I'm going to pick some intervals here, and I'm going to go for something between 0 and pi over 3. So pi over 4 is what I'm going to look at. So my f prime at x, remember, is negative 9 cosine of 3x. Let me double check that's the correct. I'm sorry, that's not correct. Something didn't seem right. It's negative 9 sine of 3x. There we go. And so pi over 4 would get me f prime at pi over 4 would be negative 9 times the sine of 3 pi over 4. And then you just have to figure out what this is. Now, I know that this is negative 9 times the square root of 2 over 2. Now the key thing here, though, is the fact that this is negative. So what does that mean it's doing here? It means we're going down. And I'll do one more interval here. Let's do something between pi over 3 and 2 pi over 3. So pi over 2 pi over 2 is between pi over 3 and 2 pi over 3. So I'm going to test that in my derivative. So f prime at pi over 2 would be negative 9 times the sine of 3 pi over 2, which would be negative 9 times negative 1, which is, again, the key thing here is that it's positive 9. And so what that means is on this interval, because we're positive, we're increasing. Now, I'm just going to give you the result here without testing the rest of the intervals, because it's just testing a bunch of numbers. And we get that it's increasing, decreasing, and everything else like this. So increasing, to write down the intervals, I'd be increasing from pi to negative pi to negative 2 pi over 3. From, actually that shouldn't be a square, that should be a parenthesis. And then from negative pi over 3 to 0. And then from pi over 3 to 2 pi over 3. And then decreasing would be negative 2 pi over 3 to negative pi over 3. Zero to pi over 3, and 2 pi over 3 to pi. Now, this is a good problem because it teaches you and reviews how to find critical numbers for trig functions. I will say that the reality is that this problem is probably too long to put on a test or a quiz, but I could easily shorten this problem down just by restricting the interval. Like I could say the interval from 0 to pi, and so then there'd only be 2 critical numbers. So don't think just because this is a long problem that I wouldn't ask this problem. I could easily modify it so that it becomes a shorter problem.